In this video, I'm going to talk about the advantages and disadvantages of the three processes that we talked before. Several aspects of these processes are compared. For example, the materials that can be joined by these processes are shown here. Regarding the welding process, almost all the metals can be welded by welding processes, by fusion welding processes. There are some exceptions that is related to the weldability of these metals, and I will talk about them in later presentations. Adhesive bonding. The metals can be joined by adhesive bonding, and by brazing also the metals can be joined by brazing. Regarding the ceramics, welding is almost impossible to be used for ceramics, as the melting point of ceramics is very high. Ceramics can be joined by adhesive bonding and also by brazing. With some surface modifications, we can join ceramics to other ceramics and also to metals. Regarding the polymers, by welding processes, only some polymers which are thermoplastics can be joined by welding processes, because thermoplastics can be melted and solidified, and that is why they can be joined by welding. Polymers can also be joined by adhesive bonding. By brazing, it is not possible to join polymers because of the problems associated with surface energy and wetting of the surfaces. So the diversity of the materials that can be joined by adhesive bonding is very high compared to welding and brazing. Regarding the loading modes that can be applied on the joints made by these processes, welding, the diversity of the loads of the loading modes that can be applied on the joints is very high. For adhesive bonding is medium, and for brazing is also medium. It is because the adhesive joints can bear the loads only in shear. It is because of the nature of this bonding. For welding, the welded joints can bear the loads in every direction, whether it is shear or it is normal load. For brazing, like adhesive bonding, we have the limitation of the joint configuration, and we can join the metals only in lap configuration. So that is why the loading modes that can be applied on the joints is lower compared to welding. Regarding the static load bearing capacity, for welding it's very good, and for adhesive bonding and brazing in comparison with welding it's good. The dynamic load bearing, in contrary to static load bearing, for welded joints, the function of the welded joints is medium with respect to adhesive bonding and brazing, which perform better than welded joints. It is because the loads that can be applied on the interface of the adhesive bonded joints and also on the brazed joints is more spread than welded joints. For high temperature applications, the welded joints show better function than adhesive bonding and brazing. because the adhesive bonding is based on the adhesives that are based on polymers, and they cannot be performed at high temperatures. They lose their properties. And also for braze joints, the maximum temperature that we can use is below the melting temperature of the filler materials that we applied, which is lower than the base materials. That is why the application of the braze joints in comparison to welded joints is lower. Regarding the weight and space requirements, the welded joints add little weight to the structure, as we can do the welding process in both configuration, as you can see. But in adhesive bonding and brazing, we add weight to the structure because of the lab configuration. Regarding the cost, the welding procedures have a lower cost in comparison to adhesive bonding and brazing because of the surface preparation that we need to do before these processes, and also because of the addition of the weight. Regarding the design diversity, the welding is more diverse than the other processes, and we mentioned it before, because the adhesive bonding and brazing can be applied only in lab configuration, but in welding we can do it in BOT design, we can do it in lab design, we can do it in T design. Regarding the surface treatment, the surface preparation that we need for welding is much lower than the other processes. For adhesive bonding, the surface treatment needs much more care in comparison to welding and brazing. For example, you can see the surface preparation for adhesive bonding. Here we have an aluminum alloy, and we did some sandblasting on the surface that we want to join by adhesive bonding. And after that we have the ultrasonic cleaning and also degreasing with acetone, which is costly and needs a lot of time. Regarding the brazing, we also have some surface preparation for brazing, but the surface preparation is less critical than adhesive bonding, because in brazing we usually use some fluxes that these fluxes at high temperature dissolve the oxide layer and the impurities on the surface. The best method to select for joining depends on what we need, on the cost and environmental factors, so we cannot say that among these procedures one is the best. Thank you for your attention, and please don't forget to like and subscribe.